In this video, we'll see the concept of harmonic components in the Fourier series. Okay, in the last class, we have seen the basics of Fourier series, and also we have solved some problems. Okay, there we have taken the square signal with the odd function nature and the square signal with the even function nature, and also we have taken the Fourier rectifier output. Okay, so those signals we have represented with the help of the complex exponential. Okay, then and also now we'll see the what is the basics of the harmonic components. Okay, in general, in the exponential Fourier series representation, x of t, a continuous time non-sinusoidal periodic signal. Okay, x of t is the continuous time non-sinusoidal periodic signal, can be represented in terms of infinite sum of complex exponential with the coefficient value. So it's like n goes from minus infinity to plus infinite, cn, okay, e power jn omega naught t. Okay, again it is omega naught is equal to 2 pi by t, where t is the fundamental time period of the signal. Okay, and also for cn, then for to calculate the cn, we are having the formula. Okay, so just if you expand this, okay, if you expand this, we'll be getting like this: a c minus infinite, okay, and e power j minus infinite omega naught t, and again all the terms. Okay, finally yeah, c minus 2, okay, c minus 2 e power j minus 2 omega naught t, and then we'll have c minus 1, okay, e power j minus 1 omega naught t. Okay, then finally the middle term, that is c0, okay, e power j0 omega naught t, okay, e power j0 omega naught t. Again, e power 0 is always 1, so we can simply write c naught also. Okay, then c1 e power j1, okay, j1 omega naught t, and then c2 e power j2 omega naught t, and again similarly all other terms. Finally c infinite e power j infinite omega naught t. Okay, so just this summation we are expanding. Okay, so now again the values of c minus infinite, c minus 2, c minus 1, c0, c1, c2, and other things will be really different. Okay, so for that separate integral is there, so we have to calculate. These are all the coefficient. Okay, coefficient of the complex exponential. Okay, so now when k is equal to 0, what we are getting, when n is equal to 0, we are getting c0. Okay, when n is equal to 0, when n is equal to 0, we are getting c0. Okay, that time we are not having any frequency. See, the exponential term is vanishing. Okay, we are not having any frequency. That's why this c naught term, we are calling it as a DC term. This c naught term, we are calling it as a DC coefficient or DC constant. Okay, DC coefficient or DC constant or DC constant. Okay, then what about the other things? What about the C1 and C minus 1? Okay, that thing we are calling it as a fundamental component. Okay, fundamental component or first harmonic component, fundamental component or first harmonic component. Okay, see, when you put n is equal to 1, okay, when you put n is equal to 1 or n is equal to minus 1, okay, we are getting c1 or c minus 1. Again, what is the corresponding component? E power j omega naught t. Here the corresponding component is e power j minus omega naught t. Okay, so this component, okay, this coefficient are called, this component omega naught is called fundamental frequency. Okay, fundamental component. Okay, first harmonic component, because the frequency of this component is same as the frequency of the non-sinusoidal signal x of t. Okay, for x of t, we have defined frequency is fundamental frequency is omega naught. Okay, because t is fundamental period. Okay, the same frequency we are representing in the exponential also. That's why again this frequency we are calling it as a fundamental component or first harmonic component. Okay, the frequency that is same as the original non-sinusoidal periodic signal. Okay, then what about the other component? When you put n is equal to 2, okay, or n is equal to -2, we'll get the second harmonic component. Okay, we'll get the second harmonic component. Second harmonic component. Okay, when you put n is equal to 2, you will get C2. When you put n is equal to -2, you will get C -2. Again, what is the corresponding component? E power j 2 omega naught t. Here e power j minus 2 omega naught t. Okay. So again, this component is called the second harmonic component because the second harmonic component will have the twice the frequency of the original fundamental frequency, but whereas the time period will reduce by half. Okay, so frequency of second harmonic. Okay, frequency of second harmonic increase by 2, whereas the time of second harmonic decrease by 2, because as the frequency increases, definitely time period of that component has to decrease. Okay, decreases by 2. Again, similarly, you can write a higher order component, third harmonic component, fourth harmonic component, something like that. So again, we can simply say nth harmonic component. When you put k is equal to say some plus n, then what you will be getting e power plus j capital N omega naught t. Okay, that means what is the coefficient that time? That time Cn. When you put k is equal to sorry, not k, this is n. Okay, when you put small n, again is minus n, then you will be getting e power plus j minus n omega naught t. Again, this is c minus n. So we'll call this as a nth harmonic component. Okay, nth harmonic component. Nth harmonic component. Again, in case of nth harmonic component, the frequency increases by the factor of n, then time period will reduce by the factor of n. Okay, so time period of the nth harmonic component will reduce time period of nth harmonic component, period of nth harmonic reduce by n. Nth harmonic component will reduce by n, because as the frequency increases by the factor of capital N, definitely the time period of that component has to decrease by the factor of capital N. Okay. Okay, so next we will take the triangular signal. Okay, for that let's try to write the exponential Fourier series. Okay, find the Fourier series. Write the Fourier series expression. Write the Fourier series expression or coefficient expression for the waveform given. Small t, again the signal is x of t, where the time is, this is 0 and this place is 1. Okay, this place is 2. Again this is 1, this is -1, this is -2. So now for this signal, this is the triangular periodic signal. For this, we have to get the Fourier series expression again in terms of the complex exponential. So First of all, we have to write the we have to make sure that which part we are going to take as a fundamental part, okay, because that part will repeat. Okay, again, we can take again, if you observe here, either we can take from -1 to +1, okay, -1 to +1. Okay, see, if you observe here, the waveform again -1 to +1, the term will get repeated everywhere. So you can assume like this, okay, in between -1 to +1. Okay, again, you take this component as a fundamental one, again, you can repeat, okay. Or otherwise, you can also take like this, okay, you can take from 0 to 2, okay, that again, you can repeat, okay, you can take both, no problem, anything you can take. But once if you take this one -1 to +1, writing the expression for this line and this line is will be little bit easy, okay, as compared to this one. Okay, once if you choose this part, again we have to write the mathematical expression for this line and also this line. Okay, then again, if you know the mathematical expression for this one, again you can easily write the representation. But whereas if you choose this one, okay, this part, again you have to write the mathematical expression for this one and this one. Okay, so it's up to you, you can choose any one. But once if you choose this one, again the mathematical expression will be a little bit easy as compared to this one. That's why we'll take this part from -1 to +1, that part will repeat all over. Okay, so then what is the mathematical expression for this line, first line? Okay, this line is going upward, so once the line goes upwards, definitely the slope is positive. Okay, definitely the slope is positive. Again, what is the mathematical expression for this line? Okay, so y is equal to mx plus c. Okay, y is equal to mx plus c. Again, definitely c will be 0 only when if the line goes through origin, but this line is not going through the origin, so definitely c cannot be 0. That means c will have some value, it may be positive or negative. Okay, then what is the slope of the line? M is the slope of the line. What is the slope of the line? Again, what is the slope? Slope is the change in y with respect to change in x. Okay, when you go from year to year, your line is going from year to year. So when there is the change of 1 unit in the base axis, okay, your amplitude is getting varied by 2, because when you go from year to year, your amplitude goes from -1 to +1. That means change in y is 2, whereas change in x-axis, base axis, is 1. So 2 by 1. So definitely the slope of this signal is 2. Again, the base axis is not x, it is t. So that's why I'll put the variable t. So 2t. Okay, so y is equal to 2t. Then what is the constant value? Okay, again you can easily predict that. Okay, when you are at t is equal to minus 0.5, your y value has to be 0. Okay, then what should be the value of c? Or otherwise, when you are at t is equal to 0, okay, when you put t is equal to 0, your value has to be 1. Okay, when you put t is equal to 0, this will give 0, but your value has to be 1, so you can put 1. So definitely the mathematical expression of this line is 2t plus 1. Or otherwise, you can check in other places also. If you put t is equal to minus 0.5, okay, minus 0.5, what will happen? 2 into minus 0.5, that is minus 1. Again, minus 1 plus 1 cancels, so your answer is 0. Or otherwise, you can also verify here. When you put t is equal to -1, -2 plus 1, again finally -1, yes, you are getting -1. So the mathematical expression for this line is 2t plus 1. So similarly, we can get the mathematical expression for this line. Okay, for this line. Okay, again, this line is having slope. Okay, this line is going downwards. So whenever the line goes downwards, the slope will be negative. Again, what is the change in y? Change in y is 2, whereas change in x is 1. So slope is negative, that's why -2. So y is equal to -2t. Again, when you are at t is equal to 1, your value has to be -1. So that means what should be the value of this one? Definitely this will be +1. or otherwise when you are at 0.5, your value should be 0. When you are at 0.5, your value should be 0. Okay, so once if you substitute 0.5 here, you will get a -1. Again, to get 0, you have to have a +1 here. So the slope of this line is -2t + 1. Okay, once or otherwise, if you are not comfortable with this, okay, you can apply the other formulas also. Okay, that means you know the 2 point. Okay, again you can take any 2 point, this 2 point or this 2 point. Then once if you know the 2 point of the line, you can easily write the equations, line equation, with the help of y minus y1 divided by y2 minus y1 is equal to x minus x1 divided by x2 minus x1. Once if you know the 2 point, you can write the equation of the line with the help of this formula. Okay, you can follow any approach, but finally you'll get the same answer. Okay, so now we got the mathematical expression. Okay, that will write it here now. Y of t, the x of t value is equal to 2t plus 1 when t varies from -1 to 0. Again, this is minus 2t plus 1 when t varies from 0 to 1. Okay, so this is the mathematical expression of the given triangular signal. Again, now please note down, this triangular signal is a even signal. Once if you observe carefully, this triangular signal is a even signal. That means when you take mirror image with respect to y-axis, again you'll get the same signal. So that's why this triangular signal is a even signal. Okay, so now we'll try to find out the C0 value. Okay, C0 value. C0 is equal to 1 by t, 0 to t, or otherwise minus t by 2 to plus t by 2 x of t dt. Okay, so that means what? The overall period is from -1 to +1. That means your limit has to vary from -1 to +1. Because what is the overall time period here? Your signal is varying from -1 to +1. So the overall time period is +2. Okay, +2 means here we are using minus t by 2 to plus t by 2. So that means again, what is the value of t? That is 2. Again, you are going from -1 to +1, -1 to +1. Again, x of t dt, x of t dt. Okay, so x of t is having different expression at different interval. So that will substitute here 1 by 2 -1 to 0, -1 to 0, 2t plus 1 dt plus 0 to 1 minus 2t plus 1 dt. Okay, now we can apply the integration. Okay, 1 by 2, 2t square by 2 plus t, 0 minus 1 plus minus 2t square by 2 plus t 1 0. Once if you apply the limit, finally you'll be getting 0 here, 0. Finally you'll be getting 0 0. Finally answer is 0. Okay, so because you have to get 0, see here, this signal is even signal, it's okay, but what is the area under this signal? Okay, within the time period. Okay, if you try to calculate the area, okay, when you are in between -1 to -0.5, this is your area. Okay, this is your area. When you are in between -0.5 to 0, this is your area. Okay, otherwise we'll put the different color. Okay, so this is your area. Again, when you are in between 0 to 0.5, this is your area. Again, when you are between 0.5 to 1, this is your area. If you see here, again, this green color is negative area. This green color is also negative area. this blue color, both blue color are positive area. So definitely the whatever the positive area that you are getting, same negative area also you will be getting. So once if you add both positive and negative area, definitely answer is 0, because C naught we can also find out with the help of what? Area divided by time period. Okay, now the area is 0. Even if there is some time, definitely the answer is 0. Again, the average value is 0. So even though this signal is a even signal, we are getting area as 0. But in the last example, we have again in the last class, we have chosen some signal like this. Okay, we have chosen some signal like this. There C naught is not equal to 0, but that is also a even signal. That is also a even signal. But now we have chosen a signal something like this, but now we are getting C naught is equal to 0. So that means what? Whenever the signal is even signal, the average value can be 0 or may be 0 or may not be 0. Again, it all depends on the shape. Okay, so so what is the important conclusion for even signal? Okay, for even signal, average value may or may not be 0, may or may not be 0, it may or may not. Okay, depending, it depends on the situation, it depends on the graphical representation. Okay, it may or may not. But whereas if you are given with odd signal, okay, if you are given with odd signal, something like this, say if you are given with odd signal, s- okay, if you are given with odd signal like this, okay, let it be a square signal or triangular signal or whatever it may be. But once if you are given with odd signal, definitely the C naught will be 0. The average value under the odd signal is always 0. Otherwise, you cannot satisfy the properties of the add function. Okay, definitely for all the odd signal, the average value is 0. So that means average of odd signal is always 0. Okay, always 0. So that means what? Whenever you have a odd signal, definitely the average value is 0, whether you calculate or not. Definitely the average value of the odd signal is always 0. But whereas for even signal, it may be 0 or it may not be 0, depending on the situation, depending on the graphical representation. Okay, so now again, this is some simple idea that you should know. Okay, what will be the average value for odd signal or even signal? Now let's continue this problem. Okay, that this problem will continue. Just we have found out the average value, then we'll try to calculate the Cn. Then what is the Cn? Cn is equal to 1 by t integration minus t by 2 plus t by 2 x of t e power minus jn omega naught t dt, 1 by 2 integration minus 1 to 0 2t plus 1 2t plus 1 e power minus jn omega naught t dt plus 0 to 1 minus 2t plus 1 e power minus jn omega naught t dt. Okay, so now in the inside the integration, you are having 2t plus 1 and also e power jn omega naught t. This is also a function of t. This term, exponential term, is also a function of t. So you can apply any mathematical formula. Again, integral uv is equal to u v1 u dash v2 u double dash v3. You can apply this formula, or otherwise you can apply uv minus integral v du. Okay, you apply in both the cases. Okay, then finally, once if you apply, Okay, once if you apply, finally you'll get Cn is equal to 2 divided by n square pi square 1 minus 1 whole power n. Okay, so this is the final expression you will be getting. Okay, so now what happens when you put again n is equal to 0, we have calculated separately. So again, this is valid only when n not equal to 0. Okay, this expression is valid only when n not equal to 0. So then what happens when you put n as a odd value? Okay, n as a odd value or n as a even value. First we'll put n even. Okay, once if n is even, again n square pi square, this will become 0 when n is even. Okay, again anything even power, you'll get 1 only. Again minus is sign is there, so definitely 0. When n is 0, your Cn value is definitely 0. So that means what? This is having meaningful value only when n is equal to odd. So when n is odd, again what is the value? When n is odd, you will be getting minus 1 power odd number will be always minus. Already one minus is there, so you will be getting 2. So when n is odd, you are having 4 divided by n square pi square. Okay, 4 divided by n square pi square. So finally, how to represent x of t? X of t is equal to 0. Okay, 0 for even values of n, even values of n. Okay, then x of t is equal to summation. Again, already c0 is 0. Again, c0 is equal to 0. So we can write n again n again odd values. Only for odd values of n we can write what is for odd values. We are getting Cn is equal to 4 divided by n square pi square, n square pi square, then e power minus jn omega naught t. Okay, so finally this is the expression. So in this example, they are given the even signal. Even though this is even signal, the average value of the signal is 0. Okay, then we are getting expression for Cn. In the Cn also, for even values, Cn becomes 0. That means finally, only for odd values of n, we are getting the exponential terms. Okay, so again, when you expand, again, you no need to put the even value. Once if you put odd values, that's enough. Okay, for the Fourier series expansion. Okay, so next we'll take the other example of triangular sawtooth waveform signal. Okay, find exponential Fourier series of the given signal. Okay, so they given the sawtooth waveform. This is from 0 to 2 pi, 2 pi to 4 pi, 6 pi, 8 pi, minus 2 pi, minus 4 pi. Again, this is t. This is x of t. Okay, again, this may be a little bit confusing because they given as t, but they given in terms of pi. But whenever pi is there, we used to think in terms of frequency, but or phase. Okay, frequency or phase. But they given t, but here in terms of pi. Again, don't get confused here. What they given here is important. They given as t. Okay, whenever they given as a t, just you imagine that this is 2 pi seconds. Okay, 2 pi seconds means what? Again, see, approximately pi is equal to 22 by 7. That means 44 by seconds. Okay, so just you don't get confused with the pi 4 pi. You just imagine like a number. Okay, because they given as t, then this is like some number. Okay, so in terms of seconds. Okay, so don't get confused with the phase and all. Okay. So once if this is the case, then what is the fundamental frequency of this signal? Omega naught is equal to 2 pi divided by t. what is the time period of the signal? Time period is the minimum period with which the signal is getting repeated. So definitely the time period is 2 pi. So 2 pi divided by 2 pi is 1. So the frequency of this fundamental frequency in terms of radian per second is 1 here. So omega naught value is 1. Okay, 1 radian per second. This is the fundamental frequency of this signal. Okay, then what is the mathematical expression? Okay, see, we can either choose from 0 to 2 pi. This is one way we can choose. Okay, either we can choose from 0 to 2 pi, that we can repeat all over here, or otherwise we can also choose in different manner, that is from minus pi, that is from minus pi to plus pi. Okay, so you can also choose this section and you can repeat. Okay, if you observe carefully, you can also do this. Okay, you can choose from year to year, then you can repeat all over on both the sides. But once if you choose like this, you have to write the equation for this line, and also you have to write the equation for this line. Okay, so you need to write two different equations. But whereas if you choose this interval 0 to 2 pi, again only one equation is enough. Only one equation, only one, this equation, only the line equation for this one is enough. Okay, once if you choose the interval from 0 to 2 pi, again only one equation of line is enough. So that's why we will choose the interval from 0 to 2 pi. We will not choose from minus pi to plus pi. But if you have a free turn, just you choose minus pi to plus pi also, whether just finally verify whether you are getting same answer or not. But anyway, now we'll do with the 0 to 2 pi interval. Okay, so first we'll calculate the average value. Okay, so now again, sorry, before calculating the average value for this line, we have to write the mathematical expression. Okay, again y is equal to mx plus c. Definitely this line is not going through the origin, so definitely c is not 0. We will have some value. Then what is the slope of this signal? What is the change in y? Okay, the again this value, this amplitude value is v. It's already given. Okay, so the change in y is v. What is the change in x? That is 2 pi. So v by 2 pi is the slope of the line. But whereas here the line is going downwards, so definitely the slope is negative. So the slope in this case is minus v divided by 2 pi is the slope of this line. Again, the variable here is t. Okay, instead of x here, variable we are having is t. So minus v divided by 2 pi into t. Again, what should be the constant value? Okay, so when your time is at 2 pi, when t is equal to 2 pi, your value has to be 0. So when you put t is equal to 2 pi, 2 pi cancel, you are getting minus v. But what should be the value? The value should be 0. So that means what? You just add 1 plus v here. Now you substitute 2 pi in this equation. So definitely you'll get 0. Or you substitute 0, t is equal to 0, you'll get v. When you substitute t is equal to 0 here, you'll get v. Okay, so again, when you substitute in between value, you'll get the corresponding values here. So now this is the equation of this line. Okay, this is the equation of this line. Okay, so now we'll start with that. Okay, so the equation of the line x of t is equal to minus vt divided by 2 pi plus v, where the interval is from 0 to 2 pi. Okay, then first c naught is 1 by t, again 0 to t, x of t dt. Okay, again 1 by t. What is the time period of this signal? The time period of this signal is 2 pi. Okay, time period t is equal to 2 pi. Okay, 1 by 2 pi, 0 to 2 pi. What is x of t? Minus vt divided by 2 pi plus v into dt. Okay, apply the integration. Again, minus v divided by 2 pi. Okay, t square divided by 2 Again, limit varies from 0 to 2 pi. In here we can write as Vt, limit varies from 2 pi to 0. Okay, then once if you apply the limit, finally you apply the limit, finally you'll be getting minus v by 2 pi plus v into 2 pi. Finally, if you do the adjustment, you will be getting v by 2. So average value we are getting as v by 2. Just will verify. Again, what is the other way of getting the average value? So the average value is equal to area divided by time period. Okay, what is the area of this triangle? Okay, so this is the triangle. What is the area under this triangle? The area under this triangle is of BH. Okay, area under the triangle is of BH because this is the right angle triangle. So definitely the area is of BH. Okay, divided by time. Time anyway is 2 pi. 1 by 2. What is the base? Base is the time period, that is 2 pi. What is the height? Height is V. Okay, divided by 2 pi. 2 pi cancel. So finally we are getting V by 2. So again, yes, already we are getting V by 2. Now also V by 2. Yes, our answer is correct. So now average value of this triangular signal is V by 2. Now again, what is the coefficient Cn? How to calculate the coefficient Cn? Cn is equal to 1 by t integration 0 to t x of t e power minus jn omega naught t dt. Again, we know that omega naught is equal to 1, whereas t is equal to 2 pi. Okay, so 1 by 2 pi, 0 to 2 pi. What is x of t? Minus vt divided by 2 pi plus v e power minus jn. Omega naught value is 1, so that's why again you can substitute here minus jnt into dt. Okay, again you can split this integral. Okay, you can split like this, minus vt divided by 2 pi e power minus jnt dt, then integration 0 to 2 pi v e power minus jnt dt. Again, v is the constant that you can take out during the integration. So again, you do the integration with the known technique, okay, already available in mathematics. So finally we will be getting Cn is equal to, finally we will be getting Cn is equal to v divided by 2 pi jn. Okay, we are getting Cn is equal to v divided by 2 pi jn. Now if you observe here, okay, again this expression is valid when n is equal to even or when is equal to odd. See, in some other expression, when we are putting n is equal to even, again that Cn will become 0. That means what? The expression is valid only for odd signal. But in this case, whether you put n is equal to even or odd, again Cn will be there, value will be there for Cn always. So that's why here we cannot put anything. So that means we have to put all values of n, let it be even or odd. Okay, so finally x of t can be represented as C naught. Okay, because we have calculated C naught separately, and again when n not equal to 0, okay, equal to 0 is Cn e power jn omega naught t. Okay, what is the C naught value? V by 2 summation n not equal to 0. That means what? The summation goes from minus infinity to plus infinity, but only n is equal to 0 is not applicable here, because when n is equal to 0, we are getting the term v by 2. Okay, then Cn is equal to v divided by 2 pi jn e power jn omega naught t. Okay, so finally we have seen the different variety of problem Okay, so in some cases, okay, in some cases C naught is 0. Okay, again Cn is present only for odd values. Okay, only when odd value of n. In some cases, C naught is there. Again, Cn is there for all n. For all n. So again, in some cases, C naught is 0. C naught is 0. Again, Cn is there for all. So we are getting different variety of combinations. So that means what? Apart from the odd signal or even signal, okay, see this C naught we can easily predict. Okay, by just looking into the signal, if it is definitely a if it is definitely a odd signal, okay, if the signal is odd, again we can easily predict C naught is definitely 0. Again, when signal is a even signal, again C naught, sometimes C naught may be 0, again C naught may not be 0 also. Again, it depends on the shape of the signal. Again, apart from this, okay, even and odd nature of the signal, we are getting this one. Again, that means what? In some cases, for all n we are getting, for all, for all n, for all n. Okay, in some other cases, okay, so in some other cases, when n is there, we are getting only for odd values of n. Only odd values of n. Okay, we are neglecting even values of n. That means for even values of n, the coefficient is becoming 0. So that means what? There is some other property that is controlling this odd values of n or even values of n, apart from the odd signal and even signal. Apart from the odd signal and even signal, there is some other property that is controlling the uh, odd n and even n. Okay, so there is some other property that is controlling the odd n or even n value. Okay, I'm not saying about the odd signal or even signal. Okay, that we are getting clarification here. Whenever odd signal, definitely C naught is 0. Whenever even signal, again C naught may or may not be 0. That's okay. But apart from this, okay, uh, n itself is having odd number or even number nature. Okay, n is a natural number. It can vary from minus infinity to plus infinity. Okay, but sometimes we are getting only odd number of n's. Sometimes we are getting both. Okay, so that means there is some other property of the signal that is controlling this one. So that is like, that is half wave symmetry. Okay, half wave symmetry. Okay, so in later classes we will see what do you mean by the half wave symmetry. Okay, so if the signal satisfy the half wave symmetry, then again there may be some distinction here. Okay, so depending on that, either we will have only odd values of n or even values of n. So there may be some distinction. So in future we will study what are all the signal that is having the half wave symmetry nature. That whenever the half wave symmetry comes, then what is the specific condition that the Fourier series expansion is following. Okay, that we'll see in the future classes. So at this moment, at this point, you just try to know that, okay, so for some expansion, n is of complete value, but for some expansion, n is of either even or either odd. It's something like that. So in the later classes, we'll see for which type of signal n is having all the values, for which type of signal n is having only even value or n is having only odd values. Okay, thank you.